Today we're on page 8 of the chapter 14 AP Chemistry packet. We're going to be talking about polyprotic acids. So the word polyprotic, the word poly means, a prefix poly, means many, as you know. And the word protic refers to protons. And remember that an H plus is a proton because a hydrogen atom has one proton and one electron. No neutrons usually because it weighs one, and then if you get rid of the electron, it's just a single proton. So we're going to look at what happens when you have a polyprotic acid. A polyprotic acid, you could almost think of it as a mixture of two acids. It's a mixture of H2CO3 in this case and HCO3 minus because it's going to give up an H twice. So the first time it gives up an H, the H plus comes off and you're left with bicarbonate. All right, an analogy of this would be like if you work in a bike shop and you have a bunch of bikes that you have to take apart for your boss. So here's the seat, here's the bike. We're going to make a very simple drawing. Okay, so you have your bike here. And what you're going to do is you're going to take all the tires off the bike. You're always going to take off the easier one first. So you want to take off the front tire. It's easier to take off than the back tire. So what you do is you have 10 bikes. You're going to take all the front tires off first. Then you're going to take all the back tires off second. All right? So it's always the same thing done until you do the next one. So you get all the front ones done, then you get all the back ones done. So it's the same thing with this. This has two H's. The first H is going to come off of all of them, and then the next H will come off of all of them. So I'll just write both equilibria so you could see it. The second H coming off is going to come off of the bicarbonate ion, and then you're going to be left with carbonate by itself. So once again, you take off the first H of all of them, then you're going to take the second H off of all of them. So to take the first H, we know that this is a 0.1 molar concentration. So we write in our 0.1 over here, 0.1 molar. In our ice chart, this is going to be 0, 0, ice. So minus X plus X plus X, and you're going to get 0.1 minus X, X, and X. You're going to set that equal to Ka1. So 4.3 times 10 to the minus 7th equals X squared over 0.1 minus X. We're going to ignore this X right here because the Ka is quite small. And when we do the math, we find out that X equals 2.1 times 10 to the minus 4th molar. And that will also pass the 5% rule. So we are okay to ignore it. All right, so that means that I'll write them in here. 2.1 10 to the minus 4th molar for the H plus. 2.1 10 to the minus 4th molar for the bicarbonate. And 0.1 minus that is still going to be 0.1. All right, so now it's like we've taken off all of the front tires off the bike. That's the easier tire to take off. Now we're going to go back and take all the back tires off the bike. So when we do our ice chart for the second equilibrium, we're going to start with the things that we already ended up from the first equilibrium. So if I put ICE, we're going to copy down the bicarbonate, which is 2.1 times 10 to the minus 4th molar. We're going to copy down the H plus, also 2.1 10 to the minus 4th molar, but we're going to have 0 of the carbonate to start with. Again, we're going to shift to the right, so minus X plus X plus X. So it's going to be a 2.1 times 10 to the minus 4th plus X. It's going to be a 2.1 10 to the minus 4th minus X. Now we're going to set that equal to our Ka2. So our Ka2 is given over here. So I'm going to write 5.6 10 to the minus 11th equals the products 2.1 10 to the minus 4th plus x times x divided by 2.1 10 to the minus 4th minus x. Again, we have such a very, very small k that we can ignore the x's that are added and subtracted. And when we're all done, we're going to find out that x equals 5.6 10 to the minus 11th, which is, of course, very, very small. So that will be the answer for up here. But if you try to add that number to this, it's not going to matter. So that's going to be the final answer of H plus. And if you subtract that from here, again, that's not going to matter. So that will be the final concentration of the bicarbonate. And once again, we notice that if you have a mixture of two acids and the second acid has such a much smaller Ka than the first one, like orders of magnitude, then the H plus that came from the first acid is not going to change appreciably with H pluses from the second acid. So you wouldn't even need to do the second equilibrium if you had to just find the pH, and that was it. So to find the pH, you're going to take the negative log of the H plus, which was 2.1 10 to the minus 4th, and that's going to give you a pH of 3.68, which is acidic, which makes sense because this is a weak acid. Now, briefly, if you had had a polyprotic that was strong, which the only one you could really have is sulfuric acid, then it would be a slightly different beginning to this problem. Because again, as you take off the tires, these tires are going to come off very, very easily because this is a strong acid. So the first H is strong. So you really don't even need to do ice. If you had a 0.1 molar, what would happen is this would turn into 0.1 molar of this and 0.1 molar of that, and then you'd have none of that because it's 100% dissociation, 100%. And then what you would do is you would do your second equilibrium, which would be analogous to this. You would have HSO4 minus yields H plus sulfate. And then when you do your initial of both of these, which will be 0.1, you're going to find out that this X in the H plus is not going to matter. It's going to be insignificant. And so if you only want the pH, you really only have to take the negative log of this H plus and you're done, because the equilibrium is not going to give you any more H pluses significantly. The only thing you'd have to do the ice for is if they asked you for the concentration of the sulfate at the end. So it would be like this. Then you'd have to do the ice calculation. But if not, you don't even have to worry about it.